Let's learn about U-subs for definite integrals. When I am looking for a U-substitution, my goal is to get an integral with a function in terms of this variable u du. We're also going to be replacing the limits of integration to be a u1 and a u2. So what I'm really looking for here is a layering of functions, and I find it right here. I've got this x cubed layered inside of the exponential e, and over here I've got almost its derivative. Let me go ahead and rewrite this. I'm just going to reorder it. So I've got 0 to 2. I'm going to put that layered function first, e to the x cubed, and then x squared dx. Let's go ahead and do that u substitution. I am going to let u be that inner function, which is x cubed right there. I'm going to let u be that innermost function x cubed. So I've got u is equal to x cubed. I also need the derivative du, and the derivative is going to be 3x squared, but I'm going to go ahead and follow this with the dx. Now I've almost got what I need to replace here, but I need to replace just an x squared dx. So I'm going to divide both sides by 3, and I've got that du divided by 3 is equal to x squared dx. So I've got almost everything replaced here. What I don't have replaced yet are the limits of integration. So x1 and x2 right now are 0 and 2. Let's go ahead and use our definition of u to replace the limits of integration. So as I'm replacing those limits, u1, which is going to be my new lower limit, is now defined using u. u is the x cubed, and inside here I'm going to go ahead and put my original lower limit, that x1, which is 0. 0 cubed is just 0. To find the upper limit, I'm going to do the very same thing. U now is going to take that upper limit and cube it. So I'm going to take 2 and cube that, and I end up with 8. So now I've got everything that I need to replace this integral in terms of u. So we end up with equals, in terms of u, my limits of integration now in terms of u are the 0 and the 8. So I'm integrating from 0 to 8. My function e is still there. I haven't replaced the e, but I have replaced the x cubed with u, and x squared dx can all be replaced with du divided by 3. So I get a du divided by 3. I can think of that divided by 3 as a 1/3. Let's bring that out in front before we integrate. So I've got 1/3, the integral from 0 to 8, e to the u du. Now I've got such a nice integral. So integrating this, I've got my 1/3, and then I take the integral of e to the u, which is just e to the u. I'm going to evaluate this antiderivative from 0 to 8. Plugging in 8 first, I get e to the 8th minus 1/3 e to the 0 power, which we can write as 1/3 e to the 8th minus 1/3, and there's our answer. In this one, I've got the integral of cosine of the natural log of x divided by x, and I'm again looking for that layering of functions. That's the best way to identify what you want u to be. So I'm going to go ahead and let u be this inner function, natural log of x. So u is equal to the natural log of x. I also need du, so I'm going to take that derivative. The derivative of the natural log of x is 1 over x, and I'm going to go ahead and follow that with a dx. Well, that takes care of all of this, which means that all I have left are my limits of integration. So my x lower limit right now is 1. My x upper limit right now is e. Let's go ahead and use this definition and find our limits. That's supposed to say limits. So for u1 is the natural log of my original lower limit, which is the natural log of 1. That's going to be a 0, so u1 is equal to 0. And then u2 is the natural log of my upper limit. The upper limit is e. The natural log of e, those are inverse functions of each other, so I just get a 1 back for u2. And I think this gets me to my goal of an integrand function in terms of u, du. I've also replaced the upper and lower limits. Okay, let's go ahead and replace everything now in that integral in terms of u. So my new lower limit is right here. It's going to be a 0. And my new upper limit is 1. And then for my integral, I still have the cosine. I've just replaced that innermost function. So I still have the cosine, but I did replace the natural log of x with u. And then everything that I've circled there in pink, this dx over x, is going to be here, and all of that becomes my du. So I've got this really nice integral to compute. The integral of cosine is sine. So that's going to be the sine of u evaluated from 0 to 1. Using that fundamental theorem of calculus part 2, I'm going to take that antiderivative evaluated at 1, and then the antiderivative evaluated at 0. Now we're working in calculus, so these are radians. The sine of 0 is equal to 0, and I end up with the sine of 1. Take a look at this next video. You guys are doing great. Thanks for watching.